Well, hello. We are now starting our seventh topic set, and this one is all about rotational motion. So we're going to have, this is going to be your rotational motion in about 5 minutes, because this is just our introductory video. And again, this is kind of going to parallel a lot of what we're already talking about, because the differences between rotational motion and linear motion are very similar. Okay, we've done everything in a line or everything linear. So now what we're going to do is going to start to look at how does this affect if we start to imagine the spinning or the rotation that takes place with all of our motion. And it adds to this because now we can not only look at just roller coasters, but we can look at the bends going around roller coasters, the turns around the roller coasters. We can also then add in all of our Ferris wheels, our scramblers, and looping starships, and all of the fun ones that we go around, or our spinny rides, as I like to call them. All right. So first thing that we want to do is we want to just talk a little bit about, what is rotational motion and what are the things that we're going to look at. When we look at rotational motion, we like to start with something like a Ferris wheel. Let me grab a color here. When we look at a point of rotation, we have our point of rotation here in the middle, and then you can see that we have some distance out to the edge, and we usually call that like a radius. Okay, and then we end up moving through some angle, and then we have some distance that we follow, and that's called like an arc length. Okay, so again, we're going to get a little bit more detail in this, but eventually what happens is we see that our point here, or our people in this like little, the carriage get to move across here at some kind of speed. And so we talk about this in terms of angular speed. We might talk about it in terms of an angular acceleration. So if we're moving fast, Ferris wheels probably move at a fairly constant rate, so we probably don't see that angle is changing greatly. But again, if we're going through, say, a roller coaster's turn, then we would have angular acceleration. Okay, and so we start to see parallels now between what we saw in a line, or our linear, versus our angular. So when we talked about lines, we talked about distances that we went through. When we talk about angular, we talk about angles that we're going to go through. When we talked about velocities, now we're talking about angular velocities. When we talked about accelerations, we're now talking about angular accelerations. And so I just threw up some symbols there that we're going to talk more about in the future. Now, not only are we seeing that, but we also see things that we like to call about like tangential speed. So in other words, we know that there is a speed that's happening at a point tangent to this circle. And as we move our way around here, we see that it's changing its direction. Okay? And so that tangential speed induces a acceleration. Okay? And that acceleration that we always end up looking at is always directed towards the center, and this is called now our centripetal acceleration. And we now get something that looks like right angles. So we see tangential accelerations, we see centripetal accelerations, which means that we would then get to do our nice little Pythagorean theorem and know that our net acceleration is always directed in between those two. Now, what causes all of these centripetal accelerations is a centripetal force. So there's always a force that's directed towards the center, and it's called our centripetal force. So we always have force that's acting on us. Now, Ferris wheel is kind of a nice thing to look at. We look at that, and then we start to extend this out and say, well, what about a bigger system? What about a system where we have now the sun and we have the earth, and there's a link between them, just like on a Ferris wheel? We're going to see that same thing where we have tangential velocities or tangential accelerations, and then we have our centripetal acceleration. So we see that we're always changing our direction here, which causes us to have centripetal acceleration. So there's a centripetal force, and this force then becomes the force of gravity. And so we're going to study Newton's law of gravity. That's one of the other things that we're going to have topic-wise. And then our last topics start to talk about our dynamics, okay? And typically we like to look at things in a form that we call statics, okay? So this would be an engineering type problem where nothing is moving and we want everything to be at equilibrium. Or we would be looking at something called dynamics where things are in motion and then we're studying the rotation and what's going on with this. We do start with something called torque, okay? Torque is kind of a new concept for us, but it's the thing that causes something to rotate. And for those of you that have ever driven like maybe a souped up muscle car or something like that, you can feel the torque of the engine. And it's almost like it makes the car want to rotate. When you rev up the engine, it's like the whole car jumps like this way. And that's torque. And that's what we're looking at. And so torque is going to be kind of a new concept that we're going to talk about in terms of rotation. We look at objects themselves and how they want to rotate, okay? And so we're going to see that there's going to be a moment of inertia. And then we translate this all using Newton's second law. And so we're going to look at things like our angular acceleration and how it makes a net torque, and then how we get angular momentum, and how there's even an angular kinetic energy or rotational kinetic energy. And so these are really all the topics that we're going to talk about in this upcoming topic set. And you can actually then go to our topic set, and you'll see that we've got our introduction, we've got angular motion, we're going to do our tangential and centripetal acceleration and centripetal force, and I'm going to try to have videos for each of those. And then we'll have some activities. The first one that we will be doing will be using this PhET simulator, and I put it up here for the introduction because I thought it'd be good for you to kind of maybe play with a little bit before we do it in class, and that'll be something that we'll look at. All right, well, hopefully you like this little introduction, and then we'll start with our next video. Will be on angular motion, okay? All right.